Hey everyone, and welcome to a new plastic scanner update video. With the plastic scanner we're trying to make a device that can identify the 5 most common types of plastic to make sorting and recycling possible and easy anywhere around the world. We do this in a fully open source way so that you can recreate it and so that people can contribute their knowledge to make the best possible plastic scanner. So in this month, March, we already realized that we're on 25% of 2022, which means that it's time to get serious. And where the first 2 months were more focused on documentation and finding our way around, this month we really set ourselves a challenge and we wanted to see if we can make a new printed circuit board within 1 month basically. So the whole process from drawing the schematics to having the board delivered, all squeezed into a time which is rather optimistic, especially with shipping times and production worldwide. But I can already highlight that we sort of managed to do something. So the last development board that we had was this one. We made it last year, and yeah, the development time was way more than a month. And in that case, in this instance, we used Easy EDA. And that was great to sort of get to know how to make a PCB, and it's very entry level. But this also had some limitations where it's more difficult to work collaboratively. And yeah, in general, the software can be a bit limiting in some sense. So we wanted to change to a new software for making a printed circuit board, and that was KiCad. On the one hand, it's open source, it's well maintained, and you can do really proper printed circuit boards. And basically what we wanted to do was make sort of an improved version of this. So still quite a similar printed circuit board, a development board which is quite big, a lot of test pads, but then with some improvements. So in the last month you saw some small budgets, some improvements that had to be made. The silk screen wasn't great everywhere and the LEDs were quite tight, so in order to be able to test with different configurations, it would be better if they were spaced a bit more. So basically that's what we set out to do. We started drawing the schematic, the PCB, we had it out for a review, so some of our friends had a look at it and they suggested some improvements, so thanks a lot Nick for doing that. And then it was over to ordering the PCB, and actually 2 days ago this package arrived and it contains the PCB. So I'm super eager to have a look, and if we open it, wow, cool! This is the new printed circuit board. It's purple and it looks very much the same as the old one, because basically it's just a small incremental improvement. So where this is development board 2, this is version 2.1, better layout of the LEDs, better silk screen, it's easier to make some test pads, and yeah, it's made in KiCad, so I'm very happy with that. Even though it arrived just 2 days ago, I couldn't contain myself, and over the weekend I sorted everything up, and well, it looks so nice. I'm very happy with the results, and so far we haven't found any huge problem with it. Still some small improvements, and I need to focus more on the labeling, so made some small problems there. But yeah, once we're happy with testing and making sure that the board works correctly, then we will release documentation on the docs. So at docs.plasticscanner.com we will be able to share how to build this, what you need to build this, and all the components that are on the PCB and stuff. But do realize that in the end this is a development board. So take the name quite seriously. Development board means it's still for development purpose. It helps you to test how infrared light interacts with plastic and how measurements change over time. And this means that in the end you are not going to have a product that is sort of out of the box ready with a screen with interaction, so that it directly gives you a type of plastic. but it does allow you to measure quite some different wavelengths. But in order to do so, we needed to have some firmware on this guy and some software on the computer, and that is where the downtime of shipping was filled in by Jelle, where he started working on making software to visualize all the readings from the InGaAs sensor, and in order to make it possible to get basically, a spectrum on your screen from the plastic scanner. So that sort of makes us a spectroscope. So we're very happy that that's now on our way, and over the time we will refine it a bit, make some small improvements, and make it ready to share, so also you can easily implement it and basically start using it and start developing it. And then we can also test with a lot of improvements and a lot of different variation. So this one makes it easier to mount stuff around the LEDs and around the sensor, because one of our experts, Bart, thank you, suggested to have like a small wall between the sensor and the LEDs, so none of the light from the LEDs will hit the sensor, and it's really only on the reflection. So also that is what we are going to work on in April, really optimizing and finalizing this so that it will be ready for you to replicate. So just a little bit more patience, and then we have something nice with you to share. And also improving gradually the firmware and the software, which basically will be an ongoing process. So over the months this will develop and expand more, but we're also very happy and open for contribution. In the end, it's an open source project. So that was it basically for March. Make sure to check in April. We've got some exciting developments, and maybe also some cool news about physical locations. But let's see for next month. And with that, I would say happy hacking, and make sure to tune in next month to see this guy working, hopefully, fingers crossed, and or some documentation for replicating it yourself. So see you!